So I'll log in. So this is the video for 10-bit LED blinking. So coming to the report, I've already explained this. So we are just modifying the count width to 10 bits, which was earlier for 4 bits. And then we are changing the assigned count to 31 to 22, which was 31 to 28 for 4 bits. Now it's for 10 bits. So and then the ALMs are remaining the same, which is 17, which was observed earlier for 4-bit, but the maximum frequency has changed to 404.53, so which is very slightly uh, increased compared to 4-bit counter. So we just start compiling this. The code remains same, just with 2 changes. So it has started compiling. It's gonna take some time. So this is where we can see the progress of compiling. So the progress is 22%, 26. And then we are going to use this pin assignment table for assigning the 10 LEDs on the board, and then everything just remains the same. I believe I've already assigned it when I was verifying it, so I just believe that it's still present on the pin planner window, which will just be looking at that. And then we are not going to see the simulation waveform for this. We are just directly implementing it on the board, and then we'll be verifying the results on the board directly. So you can see the progress 79%. So yeah, the compilation is ready, and then we have 0 errors and just 7 warnings, which we will be ignoring. So coming to the footer, so you can look at this, that the ALMs have not changed. And then coming to the timing analyzer, the Fmax is the same as what we looked in the report, 404.53. So just verifying with the pin planner. So you can just see that everything is assigned as mentioned in the document. So everything's good. Then we'll be directly programming it in the board. So I'll be using my mobile to record that. So I'm using my mobile to show that we'll be implementing it for the 10 LEDs present on the board. They're still running on the 4-bit thing. So we'll just go to the tools and then programmer. So again we are going to start with auto detect, and again the hardware setup, everything's good. Mode is JTAG. So yeah, the auto detection is done, and then we have checked this and we'll be starting it. And you can see that the progress is 100% successful. And then we'll just be clicking on the reset button to verify all the 10 LEDs are doing the up counting and down counting. So you can look at the LEDs that it's so fast. And this is because we are not looking at just the last 4 MSBs, we are looking at the last 10 MSBs. And then this is actually down counting because the direction is towards down, or it's low. So this will take a lot of time to go to 0, so we'll start putting the direction button towards up counting. So I've changed this, so we'll click on the reset. So you can just look at this, it's counting from 0. So it's still up counting, so we'll just wait till it finishes once all the LEDs are high. Yeah, we just saw that all the LEDs were high, and then we're just stopping this. So this is the power button, we just turn it off, and then this is done. Yes, and then we just directly go to the Word. This is a document where we have to answer, and then everything's done. This is done, and we have the reports. We have the reports for both 10 bits and then 10 LEDs and then 4 LEDs. So only difference was with the maximum frequency, and then the discussion results for each of the differences, why 10 LEDs took more frequency, and then why, and how is all the ALMs being same at the both versions. And then these are the homework reflection, and then coming to the summary report, we have checked everything, and then we have also done the flashing of the board using this step. So where we basically use this programmer part, and then we add the file which is converted to store it in the flash memory of the board, and then once we turn off and turn on the board, it should be toggling the LEDs based on the requirement. So this was the homework 2 part 2, which was changing it to 10 bits. So everything is done. Thank you.